Exercise 2414 asks us to evaluate three different alternatives, three projects, cleverly enough labeled C1, C2, C3. Each of these projects has the same exact cost of $288,000. So that's going to be the amount that's going to be invested. They tell you that each project requires an additional investment of $228,000 and each will yield $288,000. So each cost $228,000 and each will yield $288,000. The difference between these is how they yield the $288,000. When does it come in? If it came in evenly, if it came in a third, a third, a third, all projects would be exactly the same. Same inflows, same outflows, but there are timing differences. And the timing differences make all the difference in the world. They tell us that we use a required rate of return of 12%. So for every project we evaluate it using a 12% return. So I have to chase you back off to your present value tables. This time your N is 1, 2, or 3, and the I is 12. So if you go to your present value table for a sum, because these are all sums, for year 1 at 12%, we come up with 89, 89, 29. For year 2, N equals 2, I equals 12, we come up with 79, 72. That's not a decimal point, it's just a blob. And year 3, present value of a project, N equals 3, I equals 12, is 0.7118. Now, let's take a look. Multiply this out, we come up with 10,715 for year 1, 86,098 for year 2, 119,582 for year 3. So if these cash flows, this total of 288,000 comes in this way, the present value of those is $216,395. Our investment, same for all, $228,000. In this case, the net present value of this project, due to the time value of money, is a loss of $11,605. Now for project 2, again, same deal. Everything's the same for these problems except the way the money comes in. Notice this one, the cash flows are equal. We're going to do this as the present value of 3 distinct sums, but for those of you who are a little more financial savvy, you could also do this as the present value of an annuity of 3 years. But we'll do it the same way we did. We can use the same numbers as before because N is still 1, 2, and 3, and I is still 12. Well, yeah, it is, but so using the same numbers, 89, 29, 79.72, and 71.18. Do the math, and we find out that this works to 85.718, 76.531, 68.33. So the net present value of those three cash flows coming in equally is $230,582. Remember, the cost is the same. It's $228 for each project. Everything's the same. The only thing that varies here is the time, the way the cash flows come in. And this is $25.82. It has a positive cash flow. It's an acceptable investment. And notice the difference is only in the way it comes. You get a little bit of money at the beginning, medium amount, and a lot at the end. Here we get the same throughout. I bet you can guess how the next one's going to work out. We're going to get a lot more up front and a lot less at the back end. And let's see how that piece works out. Again, keep in mind that it's still a $228,000 investment. It's still going to last 3 years. It's simply a matter of when we get the cash. If you remember from the first part, we got a little at the front and a lot at the end. This is the exact opposite. A lot at the front, a little at the end. N is still 3, or actually N is 1, 2, and 3, and the interest rate is still 12%. Using the same present value numbers that we've done before, 89, 29, 79, 72, and 71.18, we find that the net present value of the cash flows, $160,722 for year 1, $47,832 for year 2, $34,166 for year 3. The total present value, net present value, is $242,720 minus the 228, because they're all the same. And we come up with $14,720. The difference between all three of these is simply when the cash comes in. Because you're getting the same amount of cash. If it comes in equally, your return is smaller. If it comes in back-end loaded, your return is negative. If it comes in front-end loaded, your return is positive. The longer you have to wait for your money, the less it's worth. And the next thing it says is, how would we interpret this? Both 2 and 3 are acceptable because they have positive net present value. We know that project 2 will have an internal rate of return higher than 12% because we use 12% to compute the rate. So we're good to go. The moral of the story is, the sooner you get your cash, the more it's worth.